So, good afternoon, everyone. I'm Dr. Sri Divya, and we'll be talking about the water and wastewater treatment technologies today. So, as we discussed yesterday, I have given a brief introduction about water. So, the distribution of water, its importance of water, and what are the sources of water we get it, and mainly discussed about the water cycle, how the water is getting infiltrated and recharging the groundwater, and then how it is going back to the atmosphere and getting back to the earth, and what are the different other sources of water, mainly the vegetative land cover and the wetlands, which act as a sponge effect, which take up the water, infiltrate into the groundwater by treating it naturally. And this is the comprehensive look at the conveyance system, that is the water distribution, and it is mainly starting from the glaciers and how it is going down and reaching the water bodies. And meanwhile the rivers and streams are also forming in between, and these are the natural and the artificial conveyance system. We have discussed about it yesterday. And this is the artificial system, where that is actually human engineered system, where if it is a natural one, it is going according to the gravity without any human engineering process, whereas for the artificial one, in a regulated mode, the water is transported to different areas. And coming to the other ones, that is the conveyance of water, that is canal and aqueduct, pipelines, ditches, all these are ones which are the natural ones, and these ditches are the farmers made one, by which there is a flow of water from the water body to the respective farm fields, for the farmers to easily access the water for their agriculture purposes. And this is the other conveyance of water, that is by tunnels, siphons, and pumping station. And these pumping stations are mainly used for drawing large amount of water, particularly used for the larger scale industries as well as for the high storage buildings. And coming to the water distribution process, as the water is being distributed or reaching the local water body in a regulated format, there is also a process called water distribution, where from the water body, how it is getting distributed, how the consumer, that is the how we are receiving the water, is also mainly important, that is the water distribution. And the main purpose of it is to deliver the water to consumer with the appropriate quality, quantity, and also the pressure, and to collectively supply water from its source to the point of usage. And we also require good distribution system in order to minimize the leaking effect, to minimize the problems of to keep the losses low, particularly. So these are different distribution networks of water, where one is the dead end system. And this dead end system is mainly used, the pipelines are arranged in such a way that there are several dead end systems, and connected to them, which is connected to the main pipeline m, whatever we see, this is the main pipeline, and these are the small other branches which are connected through it. And this kind of system is mainly utilized or useful in the old cities, where there is no proper pattern of roads. Whereas the conveyance of water in a radial system, if we look into radial system, is the one which is divided into different zones, and it is the distribution is in a proper way, and through the center of the distribution reservoir or the storage tank, from this the water has been evenly distributed. And this can be very useful in the high rise buildings or large industries, where if one channel is also not working, they are from the other channel, the water source can be obtained. And this is mainly very quick, offers a very quick surface, and mainly useful for the big apartments. Whereas the grid iron system, this is also one of the important one, which has no dead ends, but it carries out without any distributing the water. Even though there is a damage in the water distribution, immediately the other sublines or branches are equally effective, or able to transport the water to the consumers. So this is the another ring system where the main line is in a rectangle way, and this ring system is mainly useful in the cities with the organized road patterns, where this ring system, like these pipelines, are arranged at the below the ground. So with along with the roadways, this ring system is perfectly used, and it is very important and very advantageous, as the maintenance and the repair work can be done without any disrupting water flow. So there is no losses and no endpoint, so majorly used in the advanced cities. So once the distribution is there, even the distribution is in a proper way, we need to have the good quality of water. So good quality of water we can attain by is generally defined as the chemical and the physical biological characteristic of water, usually in respect to the suitability of the designated use. So the quality of water which we need is mainly useful for the designated use, whether it is for the agriculture purpose, for the irrigation purpose, or for the domestic purpose, or for the industries. Mainly the water quality, depending upon the use or the consumer requirements, the water quality can be defined. And it is also used for the recreational drinking, fisheries purposes, and everything. So coming to the global water quality challenges, where emerging contaminants are those which include pharmaceuticals. As we look into the picture, there are different types of emerging contaminants. One is the PAH and polycyclic aromatic hydrocarbons, dioxins, polychlorinated biphenyls, dyes and dyes containing with hazardous pollutants, pharmaceutical residues, that is nutraceutical and cosmeceutical, and chemical biological micropollutants from the agricultural wastewater, personal care products such as antibiotics, plastic disinfectants. All these comes under the emerging pollutants. These are very it is not at all easy to remove it from the wastewater. So the water quality is getting deteriorated, as there is see, as we can see there, we cannot provide a traditional water treatment process. Traditional water treatment process are the ones which we generally use the bleaching powder or chlorinated water as a disinfectant, ozonation, whatever. But these emerging contaminants cannot be removed by the traditional water treatment processes. So coming to the microplastics, these microplastics are also the emerging pollutants, where it is very difficult to remove, and huge research is going on about these microplastics, particularly coming from the industrial activities and also by the human plastic littering, where it is ultimately consumed by the fisheries, and fisheries taken up, consumed by the humans, and also the birds and all. They all are getting contaminated, ultimately leading to the deteriorated deterioration of the human well-being. So in this schematic diagram, in this also we can see from these microplastics are distributed in the air through plastics and industrial agriculture, etc. And once disposed into the air, it is getting disposal into the environment, either into the land, water, or in the air. It is directly present, and the disposal and sorry the degradation into microplastics is very difficult, and it is so distributed. And from water it is taken up by the animals, plants, and from plants and animals, or aquatic animals, again the human consumption is there, ultimately disturbing the human well-being. So this is another nutrient pollution which is majorly caused. The more amount of nutrient pollution, the eutrophication is occurring in the wastewater, or normal water bodies, where eutrophication again leading to the um, um, aquatic animals death and all. So these nutrients are nothing but the NPK, that is the nitrogen, phosphorus, and potassium. So these nutrients, when in excess, causes this eutrophication. Wastewater is nothing but the water with excess amount of nutrients which are not useful for the consumption purposes. That is the reason why it is not considered for the consumption purposes, and these nutrients has to be removed at any cost. And for the removal of nutrients, again the treatment has to be done, or else the plant naturally taking up the plants. These aquatic plants are also there which take up the water, take up the nutrients for its growth. And as well as once the nutrients are an abundant portion, these microalgae, the microalgae grow up with the presence of NPK for its growth. And if there is a dense algal population, there is a algal blooms. And because of the algal blooms, there is a much amount of oxygen depletion, because the algae is fed by the bacteria feeds on the microalgae by depleting the oxygen, because bacteria needs oxygen whereas algae produces the oxygen. And the water, the marine organisms, the marine plants are releasing the oxygen into the water, is taken up by the bacteria, ultimately causing the oxygen depletion, and ultimately leading to the aquatic animals to die from the lack of oxygen. And also plants also cannot use the photosynthesis process, as there is a blockage of sun. So this is the main problem for the nutrient pollution. Whereas for the heavy metal pollution, mainly it is causing from the volcanoes and also from the industrial discharges. These heavy metals are nothing but this lead, cadmium, and this phosphorus. All these are the heavy metals. And mainly coming from the mining activities, and accumulating these heavy metals, when accumulated by the organisms or the humans, it is posing very serious problems. So coming to the climate change impacts, these ultimately whatever the emerging pollutants, microplastics, heavy metals, apart from all these major pollutants, climate change also poses a major part in the water quality. So, with altering precipitation patterns, with increase in frequency and intensity of droughts and floods, the water quality is being affected, and also affecting the infrastructure of the cities and place living areas. So this also affects the water availability and the quality, and also affects the transport and fate of pollutants. So the once there is a climate change impact, there is more amount of acid rains as well due to the pollutant effect. These acid rains again leading to the toxic effect into the marine and biosphere process. So the warming temperature and dry and change in precipitation and runoff and sea level rise are also being affected, which are likely to continue and affect the water supply and quality. So climate change also plays a major role in the water quality deterioration. So coming to the challenges, why these challenges are more significant? These challenges, that is this pollutants or climate change, how it is getting challenged, because they threaten the ecosystem in the terms of health and biodiversity and the services that aquatic ecosystem provide. They also pose risk to the human health as well, including the waterborne diseases and chronic illness. They also have the economic impacts. The socio-economic impacts are also present due to these challenges, and mainly for the industries like fisheries, tourism, and also the agriculture. They highlight the need for sustainable water management practices and innovative solutions. By addressing these global water quality challenges requires a multidisciplinary approach, involving the scientists, policymakers. Policymakers are the business heads or funding agencies, governments, and stakeholders. All these people come under the policymakers, and also the industry and the public. So coming to the interconnected. So why are these challenges connected to the main water quality, and how it is directly impacting? What is the interconnected? Because of the ecosystem health. Ecosystem health, again, it comes under biodiversity, ecological balance, and ecosystem services, which are totally getting deteriorated with ongoing contaminants. And also, it also affects the human well-being. So, human well-being, with in terms of water quality, what is its main connection between it? Because we have consumed water for drinking purposes and also the food purposes. So, without any access of fresh water, there we cannot access for the agriculture, which is again problem for the agricultural purposes, livestock purposes, whether it is fisheries. And since it is affecting the food security, is also major interconnected for the human well-being. So coming to the public health, so public health is also has led to the chronic health problems, including cancer, reproductive disorders, and neurological damage by the consumption of the heavy metals, that is lead, arsenic, and all these substances which are inhaled or taken up by the humans. The problems will be created. And also there is a neurological damage by consumption of these toxic chemicals. And the economic development with the water quality impacts the industries like tourism, recreational, and manufacturing, clean water is essential for the economic growth and also for the social equity and cultural and recreational value. So the cycle of impact, so there are human activities. So this cycle of impact is nothing but if the human activities, due to the human activities, increase in usage of cosmetics or antibiotics and the disposal of chemicals, nutrients, and toxic chemicals degrade the water quality. Once the water quality is degraded, it harms the ecosystems. So by harming the reduced ecosystem, there is a reduced availability of the provide the essential services, either by fisheries or whatever. And this reduced ecosystem services again in turn negatively impact the human well-being, creating a cycle of environmental degradation and human suffering. This cycle also works as a positive direction as well, because if we improve the water quality, the ecosystem health improves, and also thereby improving the human well-being. So the key examples are the eutrophication, microplastic pathogens, industrial pollutants. As we can control all these emerging contaminants, if we can control, they can be a good ecosystem what we can provide. So this water quality, what is water quality? Has water quality, once we attain good water quality by not uh, contaminating it, there are some parameters which we can monitor the water quality. So what are the other parameters what we can look into is the physical parameters, chemical parameters, and the microbial parameters, which are very efficiently used for the different purposes that we will be looking into the later slides. So initially we will look into the physical properties, physical parameters, where turbidity, temperature, color, and odor are the main ones which we can directly see and tell. So physical parameters, if we see a normal wasteland or normal water body, through its color we can tell that whether it is a good quality water or a bad quality water. That is called the turbidity. So where color variation what we see. The temperature influences the dissolved oxygen levels and aquatic organisms. So if the temperature is very cold or high, or it also influences the dissolved oxygen. Once the DO levels are in a proper way, the temperature is maintained in a proper uniform way, and the aquatic organisms also can survive in a proper way. Once there is a the low levels of dissolved oxygen, the temperature might be varying. So by this temperature also we will be looking into. So this temperature mainly approximately ranges like around 20 to 25 degrees centigrade. The more the temperature, more the depleted DO levels, and also the more death of aquatic organisms are being observed. The color and odor, as we see the color, so the color also indicates whether it is in green color, whether it is in gray color. By the odor, that is the smell what we get, that is mainly due to the contamination or the organic matter presence. So coming to the chemical parameters, so chemical parameters, particularly the pH, if we look into the pH, determines the alkalinity or acidity. So alkalinity is above the pH range of 8 or 7, but the acidity is below 7. So acidity is not at all good for the water, good quality water. And alkalinity mainly poses the salinity, which again deteriorates the quality of the marine life. So the neutral pH range is around 7, and mainly for the drinking purposes, whereas 6 to 6.5 to 8.5 is the desirable pH range, which is utilized in many of the aquatic forms. So affect the solubility, this pH also affects the solubility of minerals in water, influencing the water life. And the other one is the dissolved oxygen, that is the oxygen present in the air is present in all in the marine form, also in the form of dissolved state. So these aquatic life takes up the dissolved oxygen for its survival. So low dissolve, it should be again optimum, and low levels of DO leads to the oxygen deprived condition affecting the aquatic life. Higher the oxygen levels, more the contamination. Lower the dissolved oxygen level again affects the aquatic life. So coming to the BOD, that is the biochemical oxygen demand and the chemical oxygen demand. So basically these are the parameters which are in general tell the quality of the water, whether the water quality is very bad, or it can be reused by by minimal treatments and all. So it mainly measures the organic pollution levels, mainly the bacteria present in the water, how much amount of bacteria is taking up the oxygen levels. That can be measured by this process, BOD and COD. The nutrients, that is mainly the nitrates and phosphates, and also the potassium, which causes the excess into eutrophication, which again leads to the for the marine organisms. And also the heavy metals, as we have already discussed, that is lead, arsenic and mercury, and the toxic contaminants affecting the health. Biological parameters are nothing but the E. coli bacteria. The Escherichia coli, we call it as. This Escherichia coli are the main indicator for the fecal contamination. Fecal, whether it is a human feces or the animal feces, whatever, it comes of coliform bacteria, which shows that it is the water is not at all desirable or useful for the consumption purposes. And the algal blooms, algae in certain extent they are useful in treating the water, but if it is more amount of algal blooms, there is a result from that is actually resulting from the excess nutrients and producing the harmful toxins. There are good algae bacteria, there are good algae as well as the bad algae, where good algae is nothing but it takes up the nutrients and survive properly, and we can also take up the algae for the water treatment purposes also. In many of the industries, algae is used as a biological wastewater treatment process, as algae also is having like several advantages, such as several products also can be done. First one, by doing the wastewater treatment. Once the wastewater treatment is done, it can be harvested and the powder and dried. The powder form of algae can be utilized for the producing biofuels, and also by taking the protein content of it, and also the carbohydrate content. It is having the lipid content, protein content and the carbohydrate content. And it is also like some of the algae like chlorella and nanochloropsis. You must have heard about the spirulina also. So these are the algal species which are very useful for the edible purposes as well, and also for the treatment. But more amount of algae is actually disrupting the atmosphere, like in the form of disrupting the marine life and producing the toxic chemicals and avoiding the photosynthesis process. So coming to the next one, that is water quality analysis. Why do we have to even analyze the water quality? By seeing the physical characteristic, we have learned about the physico chemical parameters and also the biological parameters. So ultimately, why do we even have to do the analysis part? So mainly the water quality analysis measures the required parameters of water following the standard methods or the protocols to check whether they are in accordance with the standards. So as I already told you, the water with desirable limits, okay, with the desirable limits, it can be used for the consumption purposes. Whether if it is deteriorating, then it has to be further used for the treatment purposes, for the primary consumption or for the utilization, whether depending upon the consumer needs. All right, so this analysis is very important to know following the standard methods and to check whether they are accordance with the standard. So why this water quality analysis required? To check the water quality is in compliance with the standards as we discussed, and hence the suitable or not suitable for the designated use. All right, so first one, what we have to do is to monitor the efficiency of the system. So first, whether if we take the lake or water body, whatever, first we have to see the monitor the system, how the water quality is maintained, as in are there any connections to the water body where there is a agricultural runoff with excess nutrients, or there is an industrial discharge, or there is any urban waste which is getting contaminated or getting mixed into this water body. So that has to be monitored first to know the quality, and to check whether upgradation or change of the existing system is required, and to decide whether changes should be taking place. So if there is any connections of these pollutants into the water body, we have to do like changes in the existing system, either blocking the contaminants entering into the water body, or any spraying the chlorinated water or anything. Like we have to decide what the changes can be based on the water body condition, and also to monitor whether the water quality is in compliance with the rules and regulations. So if we see the procedure of water quality analysis, so the procedure mainly depending upon the selection of parameters. So mainly selection of parameters, whether it is a physically it has to be treated, or chemically as well. So if we look into the selection of parameters, if it is gray water, first immediately we will be knowing about the physical characteristics. That is, we will be checking the turbidity of it, we will be checking the odor of it, whatever it is, like we will be checking the physical parameters. Then comes the selection of methods. So once we understand that why the analysis is required, when then we will go into the parameter selection. And then once the parameters are also selected, then we go into the methods. So which method is mainly reliable for this kind of analysis, whether it is a biological is cheap and best, or we have to go to the chemical physico-chemical treatment. So mainly these physico-chemical treatments are the ones which are little costly, and mainly used for the industrial or large scale water treatment processes, mainly the industries. So once the method is also chosen, the next one would be the precision and accuracy of the method selected as per the requirement. So precision is the accuracy mainly. So how exactly the method chosen is used for the requirement purpose, whether it is industrial wastewater treatment, what kind of method can be done. If it is a domestic wastewater treatment, what methods can be utilized, or whether it is a normal lake water body with a certain parameter with a high level, how much sorry, what parameter is mainly used. So the precision, the accuracy of the method should be selected as per the requirement of the water quality. And then proper sampling. So sampling, also sampling is nothing but we can do either on-site sampling, or get on-site parameters we can check. Like for example, there is an on-site pH meter, on-site dissolved oxygen meter, on-site COD meter as well, where these meters are the ones we can directly take from the lab to the aquatic water bodies and directly check by dipping the sample into it. This is called as in situ sampling. But ex situ sampling is nothing but getting the sampling from the aquatic water body to the laboratory to analyze different parameters by using different chemicals and methodology following according to the rules and regulations. So this is the sampling. Sampling will be performed either in the plastic water bottles where there is no leakage, or there is no contamination with that of one. So we will learn about the sampling and labeling whatever in the next slides as well. So proper labeling. So labeling is also very important, and preservation. So these water samples have to be preserved in a proper temperature, such that there will be no organic increase in organic matter, or there will be no biological organism influence on it by taking up more amount of nutrients from the water and deteriorating the quality, and also the analysis and reporting. So all these, from sampling to reporting, this is mainly called as chain of custody procedure. We'll be looking it into the next slide. So these water quality analysis, so mainly necessary for the public health, especially for the drinking water purposes, and also for the industrial usage. Not just that any water body is used for the industrial use. So mainly for the production of a product, or production of any chemicals. So they will be like with the water which is called as purified water, where zero minerals and zero nutrients has to be produced or utilized for the production of the product, whether chemicals or any product product called nutraceutical, whatever, for the analysis purpose or for the preparation of a product. So this unmineralized water, that is zero nutrients and zero minerals will be there, and that is mainly used for the industrial purposes. While public health, especially for the drinking water, different kind of parameters have to be analyzed by you, by keeping little amount of minerals which are mainly used for the human health, and rest can be removed by the help of other treatment processes. So coming to the selection of parameters, how do we select the parameters? Based upon the requirement. What is the requirement for drinking purposes? It has to be according to the WHO or CPCB standards. The WHO is the World Health Organization, and CPCB is the Central Pollution Control Board standards. So based on these standards, so basically the pH has to be of desired range, or the oxygen level or nutrients has to be in a certain desired standard such that it can be used for the drinking purposes. While irrigation purposes, the minimum pH, conductivity, sodium and potassium, nutrients and specific compounds are there, which has to be properly in a proper standards. Whereas for the industries, as per the specific industry's requirement, the requirement based on the industrial requirement, the parameters will be chosen and analysis will be done. And for the domestic consumption, as per Bureau of International Standards, for the domestic consumption it will be used. And for the water bodies, particularly Central Pollution Control Board guidelines will be used. And what are the selection methods for this? The selection methods are the methods used for the water quality analysis, which are selected according to the requirement. So the factors which play a key role are the volume and number of sample to be analyzed, the cost of its analysis, and the precision of its analysis, and provenance and the analysis are required. So these are the selection methods. How much, how many, what will be the cost of it, what is the precision, that is the accuracy, how correct are we going to do the protocol. So that is how we will be selecting the methods. So chain of custody procedures, as we have seen before, this chain of custody procedures are actually designed and executed to ensure the sample integrity from collection to data reporting. So collection, that is the sampling what we have already seen. So sampling has to be done in a proper way. So as like we do the sampling, but without any label, how do we know which water body, what is the condition of it, what are the things, who has done the analysis, who has done the sampling, all this will be there. So there should be a proper sampling labels. So these labels are used to prevent the sample misidentification, as well as to identify the collector as well, who has sampled it, who has labeled it, and how to maintain it, and all the label will clearly demarcate. So these are the custody of procedures, and we will be looking into these procedures in detail in the further class. As we are running out of time, we will be shutting down here, and I'll just give you a brief description of these. Sample label, sample sealing as well, and field logbook has to be maintained, and sample analysis request sheet. So wherever the sampling will be done, we have to give it for some other water testing laboratories, where those people will be requesting a sheet where they will have the logbook of how to do, like what parameters have to be considered, in which temperature the samples have to be maintained. All these will be in the present in the request sheet, or and it will be chargeable for wherever the water quality labs are there. And a sample delivery to the laboratory, how within 2 days it will be used, otherwise the quality of the water will be changed. And receipt and logging of the sample, and disposal. So wherever we want, we cannot dispose the sample in a, it should be accordance with the US UPA approved methods as well. So these are the procedures. We will be we will be knowing about this in detail in the further class. And assessment methods, what do we do, the initial testing, or laboratory analysis, remote sensing, all these we will be further knowing. And sources of water pollution, how these stresses affect the water quality and quantity, and how the water quality and which standards to be utilized, what are the challenges in water quality management, scarcity, availability, treatment, all these we will be looking into the subject in depth in the further classes. So that's all for today. Hope it is all clear for you guys. And thank you for attending the class. Thank you.